Have you ever just stopped and thought about the sounds that are, the very core of your voice? Today, we are going to demystify the vowel. We're going to explore this kind of hidden map inside your mouth that lets us create this incredible range of sounds, from an English E all the way to a French OO.
Right, so think about it. We all use vowels, I don't know, thousands of times a day. But could you actually define one? It's a surprisingly tough question, and the answer, well, it reveals something absolutely fascinating about the science of speech.
So to solve this little puzzle, let's actually look at their much simpler siblings, the consonants. Because the difference between them, it changes everything.
I mean, think about it. To make a P sound or a T sound, you have to literally block the air. Your lips come together, your tongue smacks the roof of your mouth. But for a vowel, nope, it's all open space. The air just flows right on through. And that creates a huge problem. I mean, if there's no point of contact, how in the world can linguists describe these sounds consistently? Their solution is, well, it's a little abstract, but it's totally brilliant.
So instead of trying to pinpoint some exact physical location in the mouth, scientists did something really clever. They decided to map the potential space inside the mouth. It's kind of like creating a coordinate grid for your own voice.
And here it is, the cardinal vowel chart. Now, this is not a literal diagram of a mouth, okay? It's more like a universal grid, almost like a GPS for vowel sounds that works for any language on the entire planet. So let's build this map out together. It all starts with this simple shape, right? And this represents that open space inside your mouth. Now, the big question is, how do we actually place vowels onto this empty grid? We use two main axes. Vertical one is all about tongue height. Just try it. Say E. Feel how high your tongue is up there? Now say ah. Feel it just drop? Okay, so the horizontal axis is how far front or back your tongue is. Compare E again. It's way up front with oo, where you can feel your tongue pull way back. And there's one more crucial ingredient here, lip rounding. Try this with me. Make that E sound again. Now keep your tongue in the exact same spot, but round your lips like you're about to whistle. That new sound you're making, that's a super common sound in languages like French and German. So we've got our map. But here's the thing. Not all vowels just sit still in one spot. Some of them, they like to travel. And this brings us to the difference between a single steady sound and a gliding one. So first up, you have monophthongs. These are the simple, steady vowels. Think of the ah in father. Your tongue finds a spot on that map and it just stays put. It's one position, one sound. Easy enough. But then you've got the diphthongs. These are the vowels that take a little journey. Your tongue starts in one position on the map and then it glides smoothly to another. Just listen to the vowel in the word boy. See? It starts as one sound and moves to another. That, my friends, is a diphthong. Now, here's what's truly amazing about all this. The points on this chart, they're just ideals. No language on Earth actually hits them perfectly. Think of them like stars in a constellation. We use them to navigate, but every single language charts its own unique course between them. Just take the E sound, for example. In French, it's almost a perfect cardinal vowel, but in German, it's a little bit lower. In British English, it's kind of pulled toward the center of the mouth. And in American English, we often add this little glide at the end, turning it into a diphthong. So it's the same vowel, but it's realized in 4 subtly different ways. Isn't that wild? And the complexity, oh, it does not stop there. Beyond just their position on the map, vowels can have all these special features that give speech its unique texture and color. For example, in what are called nasalized vowels, the airflow is allowed to pass through your nose as well as your mouth. This is super common in languages like French and Portuguese, and it adds a completely different resonance to the sound. Next up, we have devoiced vowels. Go ahead and feel the hum in your throat when you say ooh. Well, devoiced vowels basically get rid of that hum. They're essentially whispered, just letting air pass through without any vocal cord vibration at all. And you can hear this really clearly in Japanese, where vowels at the ends of words are often devoiced. This creates this subtle, breathy quality that's actually a core part of how the language sounds. And finally, you have some sounds that kind of live on the border. They're called semivowels. Think of the y sound in yes or the w in we. They're produced with an open vocal tract, just like a vowel, but grammatically, they act like consonants. They're like the little chameleons of our sound system. All right, so let's put all these pieces together.
We started with what seemed like a simple question and ended up with this complex, elegant map that governs pretty much how we all speak and hear.
So, what's the big takeaway here? It's that the simple vowels we use every single day are governed by this incredibly sophisticated system. They're not defined by what they touch, but by their position on this abstract map, a hidden blueprint that allows for the absolutely stunning diversity of sounds in human language.
And now you have that blueprint. You've basically gained a new way of listening. So the next time you hear someone speak in any language, listen past the words. Can you hear those subtle shifts of the tongue, the rounding of the lips, the flow of air? You've just unlocked a whole hidden layer of human language. So, what new sounds will you discover?